There are actually quite a few ways to simulate the motion of a worm gear mechanism using both core SOLIDWORKS functions as well as the motion tools included in SOLIDWORKS Basic, Professional, and Premium. Let's take a look at both. One of the simplest approaches using core SOLIDWORKS functionality is the gear mate. You might imagine the gear mate only working with gears that lie in the same plane, but that doesn't have to be the case. I'll launch the Mate tool, choose Mechanical Mates, and select Gear. For my selections, I'll use a cylindrical face from each component. For the gear mate to work properly, you must know the correct ratio. In this case, I'll use 1.5 inches with 72 inches for the large gear. Before clicking OK, I can click and drag the mechanism to see the effect. If it's going the wrong way, you can click the reverse button. Now the problem with the gear mate is that it's just a simulation of the gear ratio that's specified numerically, not a true interaction of the components. If I look at the front view, you can see the teeth are actually interfering. I'll go ahead and delete the gear mate. Another approach is to use the Move Component tool in conjunction with the Physical Dynamics option. With Physical Dynamics turned on, SOLIDWORKS accounts for each of the faces and pushes the other faces out of the way. In cases like I have here, this can be a bit of a resource hog and may not show you smooth results. So let's turn our attention to the motion study tools. As of 2008, SOLIDWORKS has included animation and basic motion tools that are provided with every seat of SOLIDWORKS. And if you have SOLIDWORKS Premium, as I do here, you also take advantage of full motion simulation. In this case, basic animation really wouldn't be the best solution. Animation simply provides keyframe animation and wouldn't take into account any physics or contact between components. Basic motion, on the other hand, does. There are only a couple of steps needed to make this work. First, I'll add a motor to produce some movement in the system. I'll use an edge of the crank to specify the motor location and direction. I'll make sure the arrow's pointing the right way and type in 30 RPM for the speed. I'll click OK, and the motor is added. Next, I have to add contact between both components. I'll press the Contact button, select both of the parts, and click OK. At this point, SOLIDWORKS has all of the information it needs. It reuses the mates in the assembly and calculates the motion with the parameters we specified. Now if I play the animation through from the beginning, you can see it's not the smoothest. The gear sort of lurches forward until it hits the next thread of the worm gear. The reason this is happening is because of something called a penetration condition that cannot be adjusted in basic motion. To make a long story short, basic motion allows the faces of each component to penetrate each other, and then applies the force to realign the surfaces to be touching. Why, you might ask? The answer is speed, so SOLIDWORKS can crunch the calculation quickly while keeping the tool relatively simple to use. In the full motion simulation package, on the other hand, you have full control over the penetration condition, so the animation can run smoothly. I'll switch this to a motion analysis study, and then recalculate it. The default penetration setting in full motion is set much lower, which also results in a longer processing time. But when the study's finished calculating, the motion's quite smooth. So, we went over quite a few ways of showing motion on a worm gear mechanism. For more information about creating the worm gear model itself, check some of the previous lessons in the Ask Solid Professor archive, or Solid Professor courses on helixes, and even threads.